Hello, this is Elemar Jr. and today we'll have a talk about NoSQL databases, RavenDB, CosmosDB, .NET ecosystem, and so on. As you noted, I am talking English. Don't worry about that. We will provide Portuguese subtitles as soon as possible. The reason why I am talking Portuguese in English, I'm sorry, is because we have a very special international guest. Today we'll have here my friend Oren Eini, who is international blogger, Microsoft MVP, CEO of the Ayende Rahien company, a company that develops software named NoSQL database, a NoSQL database named RavenDB. Also, we'll have today my friend Thiago Custódio. Thiago Custódio is a Brazilian guy living in the United States right now. He is author of some books in Portuguese about artificial intelligence as a service. Welcome, guys. It's very nice to have you here.
Hi, Elemar. Thanks for having me.
Yeah, that's a pleasure. That's a really pleasure. My friend Oren, let's start with you. What's new in the NoSQL world? Recently, we have seen some traditional databases getting some NoSQL-like features. Also, document databases like RavenDB are getting some features like graph features. It seems that the boundaries are getting blurred. Do you agree with that?
Yeah, I think that what's happening is that in many respects, there used to be very hard separation. You had the relational database, and you have a document database, and you have the graph database, and we didn't have the capability of supporting multiple models under a single system. Another thing here that is important is that the complexity inherent in a database engine is quite high. But the moment that you have an engine, repurposing it is relatively easy. And I want to point out to Postgres JSON columns, which allows you to do sort of like NoSQL fill inside the relational database. At the same time, if you compare something like RavenDB to Postgres with the JSON column, you're going to find that there are some interesting differences that are building into the baseline architecture. For example, Postgres is a single primary server. It's impossible to, extremely hard to run it in a system where you have multiple concurrent nodes. All of them are accepting writes. With RavenDB, that's something that would be absolutely trivial. That was something that we did in the baseline design. Other things that are important are what does it mean for the actual production usage of a feature? And for example, RavenDB can do graph queries. And if you need to do some basic things, go right there and do that. If you want to squeeze every little bit of graph operations out of your system, go for Neo4j, go for one of the dedicated graph engines, because that's what they do. But I think that what happened is that for many use cases, you don't need to be at the 99.99 percentile to be effective. If once every now and then I need to store some schemaless data in Postgres, JSON columns makes perfect sense. And they solve the problem. I can move on and do other things. Whereas a great example would be a search in general. It used to be the case that you had a separate system, Lucene, Sonar, Elasticsearch, just for your searches. With RavenDB, you have full text search built into the system. It's just another line there with the full capabilities that you might get from Sonar or Elastic. But why do we have that? We have that because search, as important as it is, actually isn't the whole solution. And more you start to see people who want to have a complete solution in one location by one software. And why is that? Because what happens if you don't have that? What happens if, okay, I'm using a Postgres for storing my relational data. I'm using a Mongo to store my document data, Elastic to store my search indexes. Well, who is going to do all of the integration between them? And that is a non-trivial amount of work that you've just taken upon yourself. And okay, let's try to do coordination with multiple distributed systems. Each one of them has their own idiosyncrasy. Each one of them has their own behavior, failure mode. And that's a very, very close definition to being in hell. Because think about it.
Yeah, that's insane. That looks insane.
So I think that for the most part, it's like saying, okay, I want a car. Now, I want a car that will take me to work. Okay, that's boring. I want a car that will be fun to drive. Okay. Now, I can get a Ferrari, but I would spend a lot of money. I would have lots of fun driving that, but probably not something that would take my kid to kindergarten with. So there is still a very much a time and place for the specialized tools. But even with a specialized tool, I still want to do all of the usual stuff. So in a Ferrari, we'll find a luggage compartment. It's about this big, but you have a luggage compartment.
Yeah. I understand that. So changing the subject. Recently, Ayende Rahien has announced tooling for CosmosDB, a concurrent database from RavenDB. What it means exactly? Being CosmosDB the new kid on the block, how do you see the competition between RavenDB and CosmosDB?
It's really funny. If you think about why RavenDB was created, it created out of sheer frustration with the situation that we had at the time. And the problem was that at the time I was a database performance consultant. I would go to client after client after client and tell them, this is what you're doing wrong. And I kept saying the same 5 or 6 things every single time. And eventually I got tired of that. I said, you know what? I bet I could automate that. I bet I could generate a report for the client telling him, here are the same 16 that you do wrong. And I know I could do that because I accidentally sent one client a report of another client. And they came back with, oh wow, that is really insightful. I'm like, oh dear, I sent you the wrong one. And one of them was in insurance, and one of them was in real estate lease management. I'm like, you don't have a policy in your domain. And somehow my commentary on the policy repository was insightful because it was all the same crap. And eventually what happened was that I created a tool. We call it initially the NHibernate profiler, and it branched out to be 5 or 6 profilers covering most object relational mappers in the .NET space, Java, and a few others. And what this profiler did, it sat between your application and the relational database. And it analyzed all of the traffic. And it was able to tell you, here are the things that you're doing which are wrong. Now, every database in the market has a profiler. But the problem is that what they focus on is very much the wrong thing. They're focused about about the set of queries that are being sent to the database. What a developer, and that's something that as a DBA it might be interesting to me. But as a developer building a system that uses database, what I care about is the interaction of the application with the database. So I want to understand, okay, I hit this endpoint and I generated 4 queries to the database. 3 of them are superfluous. Or I can see that here I made an index, I made a query that didn't use an index. Here I'm doing a query without specifying a limit. So I need to show tell result, I got 10,000. Those sort of issues. And what a profiler is able to do is to tie the event, the action that you have generated against the database, to what is actually happening in your code. So now you have, okay, here all of the things that happen as a result of this button click, and here is the line of code in your code that generates that. And now you can see that you're accessing the database through a single-threaded value for multiple threads at the same time, and a whole bunch of other stuff like that. Now, this has been my primary product for a while, and then I realized that even with the profiler, people still couldn't get good experience on writing data-driven software. This is where I decided, you know what, it's time to bite the bullet and just write my own database, hence RavenDB. Now, CosmosDB came out, I think, 3-4 years ago. It was originally called DocumentDB. It is a really interesting model, not just the internals, but because you get charged based on something called provision capacity. And that's really interesting because typically you're charged based on, oh, you have a license, or in the cloud, here is the how many cores and RAM and disk you get. This is what you get. In Cosmos, you're charged by what is the maximum number of operations per second that you're allowed to use. Now that's really interesting because what it means is that you have to pay for the maximum amount that you will ever use. So let's assume that you have an application, and that application is typically doing 5 operations a second. At 9 a.m. every second Monday, this application needs to do 200 operations a second. Okay, now you have to pay for 200 operations a second. Now, in general, it's not always like that. Sometimes you have, I have this end-of-week report, stuff like that, that really generate additional work. But in many cases, the problem is that as a user, as a developer working against CosmosDB, I'm being charged on the number of operations that I execute. And I've seen that with relational databases, it's almost impossible for a developer, team lead, anyone in the team, to look at a piece of code from the outside and say, how many queries is it going to generate? Because, okay, I have an architecture, I have services, I have repositories, I have caching, I have a whole bunch of stuff going in the middle. And, in this case, he clicked on this checkbox, so I need to get some additional data from here, and something crazy like that. So the idea came to me was that we are able to utilize the same core engine that is able to analyze the interaction between a relational database and your application and teach it about CosmosDB specifics. So, for example, the most trivial thing that we give you is, okay, here is an operation, here is a web request that was made in your system, and that web request is now generating X number of operations. It's going to cost you 35 cents per call. Okay, now we have something actionable. Now you can look and say, okay, now I know what to do, how to fix that. And then on top of that, we looked at the full set of documentation. We talked with the CosmosDB team, and we tried to provide you with additional information and guidance. So now we're able to say, oh, I can see that you're making a query. That query is using an expression that cannot be translated into an index, so you're actually scanning the entire data set. Welcome to a huge expensive bill, or 427 error from Cosmos, which basically means that you're now unavailable. We had seen stories about customers using CosmosDB where 70% of the Cosmos bill was one line of code.
Oh.
One line of code that...
really?
Yeah. They moved one line of code from being called on every method invocation to be in a singleton, basically the creation of the CosmosDB client, and 70% of their build just went poof. There is a really good description of that, and the person giving the description goes on, oh, we've done this, we've talked with the CosmosDB support team, and blah, 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 blah. Eventually, we managed to figure it out that this is one line. we need to put it as a static variable instead of a local variable inside the method. That's it. And it shouldn't be this hard. So this is why we created the CosmosDB profiler, in order to answer that specification.
Okay, I got it. Thiago, do you have any consideration here?
Well, I'm curious to learn more about this profiler, actually. So do you think it can be used to not estimate, but to compare the price that Azure is charging you against what actually should be charged, or it does not focus on cost?
Yeah, so here's an example of optimization that you can apply. By default, with Cosmos, every single index in your document is going to be indexed. You're charged on that. You're charged on the computation cost and the storage cost of those indexes. The profile is able to tell you, here are the set of indexes that you actually, the set of fields that you're actually going to need. So it says, oh, only index those fields, and that works. Other things that you can do, you can say, okay, you know what, it's the most trivial issue ever. How about I ask you, give me all of the people whose age is greater than 30? Doesn't sound like a complex query, right?
Yeah.
But how do you actually usually express it? Birthday minus now greater than 30 years. Now, what's the issue with this? This is going to do computation. You just introduce the now function, which typically means that it has to be called per row. So, okay, no indexes, table scan, poof. On the other hand, you can use birthday greater than now minus 30 years. Notice that in this case, the now minus 30 years is a constant across the entire query. So I compute it once, typically on the client side. And then I send you the date from 30 years ago. It says, okay, give me everything that's bigger than this value, which is perfect for running an index. This is a very trivial range query. So now you have the exact same query expressed very slightly differently, and you have huge impact on performance and costs. Now, the actual problem isn't so much that you're being billed excessively. The problem is that you are billed on the maximum capacity that you reserve. Now, what does it mean in effect? You go and build an application, and you spend, let's say, a minimum of 3 to 6 months on it. Now you have to actually go to Azure and run it live. What are you going to put in the value? What is my reserve capacity? And the answer is that you're probably going to pull a number out of your ear. And in many cases, that number is going to be either too low and poof, the system goes away, or it may be too high. And in most cases, that what we've seen, it will be significantly too high by multiple factors in some cases, just to cover the edge cases. And then you end up paying a huge chunk of money for essentially extra capacity that never gets used. With a profiler, you can run it. You can run your own benchmark and load testing to see, okay, this is the behavior of the system on 500 users, 5,000 users, stuff like that. Okay, makes sense. Now I can do a computation, how much I actually going to need, and get something that is much closer to the real thing. And you can also say, you know what, I can see that according to the current system, supporting 500 users would cost me, I don't know, $200 a month. Supporting $5,000 would cost me $2,000. I can't afford that. So I need to rethink my architecture. I need to rethink my approach. But you get to do that not after, your credit card's already been dinged for $2,000 a month because, I'm in production, I have no time to fix it, just pay someone, let's throw money at the problem, and then try to fix it later. You're gonna do it quietly in a air-conditioned room while you have weeks or months before you actually do the release.
Yeah.
That's a huge difference.
Yeah, and let me understand something in the strategy thing, the commercial thing. CosmosDB is a kind of competition for RavenDB. How do you see this competition, and what do you expect for the future?
Cosmos and other things like DynamoDB on AWS and Spanner on Google are all tied to very specific cloud platforms. They're tied to very specific architecture and users-based billing. Now, they also tie you to some really complicated structures. So let me give you a good example. If you run with DynamoDB, which is AWS managed scale as big as you want a database, you also have this idea of a reserve capacity that you have to buy. But this is reserve capacity divided by the number of partitions that you have. So let's say that you bought a capacity of 1,000 requests per second. That's a lot. You have 100 partitions, each partition 10 gigabytes, sorry. Each partition gets 10 requests per second. What can you do with 10 requests per second? So, and if you have a hot partition, well, now you have to pay the capacity for this partition multiplied by the number of partitions that you have. So suddenly you realize that you have a really interesting situation in cloud databases. There is now economic incentive built into the way that you run your queries. Cosmos, Dynamo, Spanner, all of them do something like that. And you realize that a significant chunk of the effort involved in building those is around managing those costs. Now, with RavenDB, you're not going to be able to get to the petabyte scale. But we have multiple customers running with terabytes and tens of terabytes range quite easily. And the key here is that, if you're running in the cloud, then you have a very fixed cost, which, this is how much you pay, and you don't really need to think about that. And one of the things that we have been doing is trying to reduce operational complexity, reduce the overall overhead, stuff of this nature. Another thing that is really important is the kind of deployment strategy that you have. If you're running purely on the cloud, purely on one cloud platform, you might want to use one of those. But if you need to mix multiple clouds, running the edge, on-premise, all sorts of things, suddenly you realize that you get into much more interesting work. And with RavenDB, those sort of topologies are not something that you have to fear. It used to be, I used to have a joke. I would do RavenDB training. I would go and ask, okay, who here is the DBA? And one of two guys would raise their hands. Okay, when was the last time you set up a relational database class, distributed cluster? And the number went like that. If this is Oracle, it tends to take multiple weeks. SQL Server, 5 to 10 days. Postgres, about a week, those sort of things. This is the amount of time that it took you to set up and test and verify that, a relational cluster works. Okay, pull up your stopwatch. We're setting up a RavenDB cluster. And I think my record is under 75 seconds. And, I mean, the difference in architecture and complexity is huge. Let's say that the example that I like to give, let's say that you have a clinic and multiple clinics, and you need to store details about the patients. And you need to sync those details between all of those clinics. So if you go to the clinic in your hometown, they have your details. If you go to a clinic for the same provider in a different town, they also can pull up your records. At the same time, you're going to need to be sure that, if there is no internet connectivity because a lightning hits the wires, I still need to be operated. Now, if you're running on the cloud, well, no connectivity, no cloud, okay, we're done. Get me some pen and paper. If you're running with Raven, the ability to run a local node is built in the same sense that we use DNS today, and we have a DNS recursive resolver and repeaters, all those sort of things, to give you a robust infrastructure. RavenDB is used in those scenarios where the cloud database are just not relevant for the story. Make sense?
Got it. Thiago Custódio, did you have any consideration or question here?
Actually, I would like to know more about Raven. So, since you made that the recent version, it's Raven 5, right? And it was released a couple of months ago. I would like to know what kind of features and enhancements that you released in this new version comparing with the previous one.
Okay, so the upcoming version is 5.0. It's going to be released at the early July.
Yeah.
So I'm going to talk about this one. The primary feature that we have for this version is the notion of time series, and I'm going to just show it here. Let me see if I can share the screen.
Awesome.
Share screen, and here you go. Can you see this?
Yeah. You're live.
Okay. So I'm just going to spin up the cluster. A bunch of options that no one really cares about right now. I'm selecting the 5.0 version. We actually run it in Brazil. Actually.
Awesome.
Yeah.
Oh.
Okay. Okay, so what I'm doing right now, this is using the RavenDB cloud infrastructure, and we're going to create an instance in Sao Paulo. You can also run RavenDB on-premise on, what is that? I just had it a second ago. That's it, that's annoying. I had a Raspberry Pi here that I'm using to test RavenDB, and there you go. So what you can see here, this is a RavenDB. This is a Raspberry Pi 3.0. It's running a RavenDB on Raspbian, and it's a pretty standard Raspberry Pi. It can do everything that RavenDB can do, and that's kind of funny. And I can actually have a demo where I show how I connect a Raspberry Pi running, in some garage somewhere with the cloud to be able to pull and push data. Now, this is going to take about 2 minutes to set up. So in the meantime, I want to talk about, in general term, what does it mean to have time series data? And great. Okay, I cannot do that on proceed. Let's try another one. Let's do the live test. This is a public instance that anyone can use. And I will be sure to check why the setup failed after. So now this is RavenDB. You can see some employee data. JSON, not interesting. You can see here we have attachments. An attachment is just a way to add some binary data to the document. Very similar to how you do attachments in an email, basically. You can also have counters, which is a way to do high-frequency countings, but this is the interesting thing. Now we have heart rate for this employee. We can go here and see that this uses a Fitbit, and apparently here is the heart rate for this employee. I can also go here to this company and look here, and here are some financial data for this guy, for this. Now, what is time series data? Time series data is data that change over time. My heart rate right now is X, tomorrow it's Y, and I don't actually care very much about what my real current heart rate is. Care about what is my average, how often it spikes beyond a certain value, those sort of things. Same here with stock prices. Now, RavenDB allows you to now record entries in a time series attached to a document. We're doing that in using an algorithm called Gorilla compression, which allows you to create very minimal, to record very minimal amount of data in order to record one of those. You can see this is quite a lot of data that you see on the screen. This is about 12 bits or 14 bits, depending on which entry we're looking at, that we need to record that because we remember a lot of stuff from previous or need to keep track of differences and stuff like that. You can also go here and query. So ID, I think that was employee 1. Heart rate, and we don't have a lot of data. Let me try to, 1 minute. So I can see this employee heart rate over time. And the interesting thing about this is what happens when you write it on massive scale. We have one of the issues with time series data is that you have lots of it. Try to imagine that I'm recording my heart rate once every second, pretty much forever. I have a Fitbit here, and it records my heart rate. And apparently I've been wearing that for 5 or 6 years. So I download my heart rate over time. I have over 12 million points of heart rate over time. I can track it and see trends and stuff like that. Time series is heavily used when you're talking about monitoring metrics, IoT, all of those sort of things. And you have to deal with a lot of data, and you have to deal with really annoying requests. Okay, find me all of the high points per hour for the last 30 days, and show me everything that did we ever had a mean and a high that are more than X apart, those sort of things. Time series is also used for analyzing financial data. Now, as the data grows, RavenDB is able to do some interesting things. It is able to do automatic roll-ups on the data. So you have per minute, you have here multiple time seconds we record an entry, but now I want to have a per minute, per hour, per day queries. And that's not that interesting. But what RavenDB is able to aggregate a lot of those things up front. So when you make a query, and that query may be in a huge range, or show me the average price per sale per day for the last 30 years on this talk, which I have 40 years of history on it. So Raven is able to generate that kind of answer within milliseconds. We can actually do better than that and define additional rollups. I will say, you know what, my heart rate, not that interesting to me. I don't really care that much about it. I want to know, you know what, group it by 1 day and then delete it. So I'm going to keep the raw results for 5 days, but I'm going to aggregate that on a daily basis, and that's it.
Wow, that's great.
Yeah, so the idea is that you're going to want to, as much as possible, reduce the work that you need to do in order to answer questions. Now, notice that in this case, I still want to make queries over the employee's heart rate, and I'm able to do that transparently, both on the raw data on the daily aggregation. Yes. So that's one big feature that we have for Fiber.
Awesome.
The other big feature is called documents compression. And document compression is an interesting feature because it's really boring. Now, what does it mean to have documents compression? Let's go and create a new database, and I would be able to answer that. And now I'm going to create a sample data.
That's a feature that I love in RavenDB. You have everything you need to start learning just from the studio. You don't need to create documents. You can use sample data. So
yeah, and it helps a lot in getting good performance. So in this data set that I have right now, I have a total of 830 orders, which is a minuscule amount. So let's what I'm doing right now, I'm saying, okay, take every order. Yes, sir. Update. I know how to spell that. Take every order in the system and put 100 copies of it. Let's run it again. And now you can see here that the number grows. And we'll let it run for a bit. And what interests me the most is I want to look here. Now we can, by the way, notice that I'm drilling down into the details of how it really works. And see this guy. I have 99,000 here when I'm operating more. And this would run for a while, so let's kill it. Now let's go back here and see how much data we currently use. So the order tables now takes 174 megabytes. And now I'm going to do something interesting. I'm going to go here and say, you know what? Orders is compressed. Now, in order to actually enable the compression, I have to make a modification to the data so it will know that I need to compress them. I can also do this. Where is test? Compact database. Indexing doesn't matter to me. And okay, we're done. And now let's see what happened. So it went down to a third of its previous size.
But this to do that, you changed the internal representation of the data. I have some.
Let me try to explain how it works.
Okay.
So when you're working with a compression, data repetition is awesome. But with JSON documents, you realize that in a lot of cases, you have a lot of repetitive data. Last name, address, all sorts of things. The structure of the document. As well as things like, okay, I'm going to have a lot in this data set. I'm going to have a lot of 1994. I don't need to repeat it every time.
Yeah,
So-
it's pretty much the same idea as a column index store, for example, and things like that, right?
Yeah. So, but now we run into an issue. RavenDB is a schemaless database, and we treat all of those documents as individual. Now, going ahead and compressing this value independently would save you some data, but not that much. If I was able to compress all of the results into a single compressed value, that would give me the best results. But that would also mean that if I want to get employee 4, I have to decompress all of these values before I can get to this one. So instead, we use a different scheme. We look at your data, and we sample the documents, and we build a model. And this model allows us to find all of the commonly recurring strings inside the data. And that model gets translated into a dictionary. Using this dictionary, I'm able to do two really interesting things. I'm able to take this and with the dictionary, get a compression ratio that is almost as good as compressing everything together. And what's more important from our perspective, I'm also able to say, okay, I need to decompress this. So with the aid of the dictionary, I can decompress that independently. So each one of these records is individually compressed using a dictionary, and we're able to operate that individually as well. Now, there is another issue here. If I just sample documents at some point in time, then my document change. Or you're looking now at orders from 1996, but now we're in 1997, we're 2000, so we're relevant. Or you're looking at documents that are created by version 1 of the system, we're now at version 3. So one of the things that RavenDB does is it measures the rate of it measures the compression rate that we have compared to the actual rate that we need. And one of the things that it does, it reevaluates the things that it needs to do as we do. You can see that in this case, we actually have a total of 7 compression dictionaries that we recreated as the data changed to give you the most optimal compression ratio. Now, this actually matters quite a lot because, again, looking at this, I'm now running on a third of my data. Now, a third of my data is quite high to, I mean, we discarded 66% of the data also, more than that actually. But more typical scenarios, we give you slightly higher than 50% reduction in disk utilization. And now, remember that I said that, oh, what happened when you run in the cloud? One of the things that happen when you run in the cloud is that you pay on storage. And now we have 50% reduction in storage costs. And we've tested that it has an impact. We have slightly higher memory utilization, we have slightly higher CPU utilization because we have to unpack the results. But from the point of view of your client system, nothing has changed. From the point of view of your overall system, you have a lot of spare capacity. Now, just to give you some idea, this is a T3 micro or small or something like that. This is a really small instance in AWS. And it was able to just handle that without us really needing to think about it.
So,
yeah, so
that's awesome. Changing the subject, Oren, we know that RavenDB is written in C#, but it's a very different kind of code, C# code. It's not trivial. It's not line of business. We know that in the past that adopting .NET was a challenging decision, but now .NET's getting better and better in subjects about performance. How do you see the evolution of the .NET ecosystem? What to have to say about that?
I want to show you this guy. This is this.
Yeah.
And this is this. Those
Yep.
are the second power benchmarks. This
Okay.
is the standard benchmark for web serving requests. You can notice that we have here ASP.NET serving 7.3 million requests per second. That's per second.
That's amazing.
Just to give you some idea, let's say that you have an application that has 20 requests a second, which is a respectable line of business application. This is what it does in an hour. This is what it does in a day. So you have to do a whole work week to do enough requests to match what this does in 1 second.
Yeah, that's pretty insane. That's
Yeah.
pretty
Now,
insane.
if you go to the same benchmark 3 years ago, ASP.NET was, maybe I have, there you go, somewhere on here. So
Wow.
we're literally talking difference of 0.1% of what the top could do. And this is in location 384. And we started RavenDB in 2010. And at the time, what I was most concerned about was productivity and ease of use of the product. It didn't take me very long to realize that I needed a lot more performance, no matter how much you get. I guarantee you this number is going to be higher next round. And in 2015, we ran out of steam for the architecture of RavenDB as it stood at that time. We couldn't get it to do what we wanted because there was so much stuff in the middle. At the time, .NET Core, which was then called .NET DNX, was just started. We moved to that, and we took the time to re-architect effectively everything in the system. Now, you will notice that this is doing plain text operations. This is just return a constant. RavenDB is able to do, on this machine, on a Raspberry Pi, 13,000 requests per second, which actually do something with the database.
13,000.
Yes. On one of those machines, we exceed 1.5 million queries per second. That means give me a document, give me a random document, and you get that. And that means that you lose some amount of caching, so you're only as fast as some of those, which is still absolutely ridiculous. But fun fact, this guy is written in Lua, which is a scripting language. Yeah. Anyway, so we spent a lot of time optimizing, and it turns out that .NET could always do that. .NET, it's actually really impressive if you think about it. A lot of the improvements that were brought into the framework wasn't to introduce new capabilities. It was to introduce new existing capabilities in a nice manner. Because .NET always could head start, always have the ability to directly address memory, those sort of things. And one of the best things that happened with the move to .NET Core was that the entire community now has a vested interest in improving performance. And you see, oh, I can. If you look at the list of commits for .NET Core, you see stuff like, oh, reduce allocation when doing an index of on array under so-and-so condition.
Yeah.
Which is, it's not really, in the grand scheme of things, outside of some artificial benchmark, you will never see that. But once you start having thousands of those changes, they have this disparate impact when they come all together. And suddenly the performance starts being, okay, 0.001% higher, 0.002% higher, and they compound. And then you end up at the top of the list.
Yeah.
Yeah. And again, some of those things, let's see if I remember. Some of those things are written in C, which are dedicated specifically to beating this benchmark. It's just ridiculous. There was a Kilobyte wrote a HTTP server in C, and she used this as a benchmark. And it wasn't near as much as this. And it's not just that the hardware is better. That's the fun part.
Yeah. In the past, you've written a lot of tricky code in C#. Using direct access to the memory and memory files and things like that. Today we have a lot of features in C# that help us to write very performant code. Are you changing the code? Are you changing the tricky code from the past?
Okay, so it works, and it was hard to write it. Let me see if I can show. Okay. Let me show you something.
Now we're using Rider.
Yeah. I'm using. It's funny. I'm using Rider to write code, but I'm using a Visual Studio for debugging because Visual Studio as a debugger is amazing. Now, what you can see here is that I'm taking a long and a char pointer, and I'm doing this is relatively tame. And again, doing stuff like this to generate the values. We now, and eventually this gets turned into, and if you look at this guy, then not this one, I did not look in. And then we have someone who will do a fix on the string and do unsafe lookup into the string. Here we go. So you have something like this.
Yeah.
Now you have a now you have this, and I'm going to say 27. What is okay? And now I can do the same thing, but safely.
Okay. You don't need to write safe code.
Yeah. That's really nice, but I'm not touching this code. That was bad enough to write as it is. Now, here is another example of, this is the piece of code that is responsible for reading commands from the network and parsing them, so we'll be able to understand as soon as possible what the command is and how to process that. Okay, so this looks like this. Now,
What
the
about
issue.
magic numbers, right?
Yeah. Now, let me show you. What is this magic number? This is actually saying something like this. Let's take counters, which is 8 bytes.
Yeah.
Translate that into, take the ASCII codes of that. Translate that into an int64, which is 8 bytes, and do the comparison in a single machine instruction. Same thing here, but with ints. One machine instruction.
Yeah.
And this goes on for quite a while like this. And this is scary and unmaintainable, but it is maintainable. We work with that. We can see very clearly what one of those is doing. But the whole idea is that the reason it matters is that this, in this case, instead of doing 11 machine instruction, we have 1.
Yeah.
And there is a significant amount of difference. Now we have a whole bunch of stuff like that.
So you're writing C# code, thinking about the assembly code, and that's kind of crazy. But
Yeah.
it's important to say that it would not be different if you were writing this code in C or C++ or Rust. You would need to take the same kind of caution.
Yes.
Yeah. So the problem is not C#. The problem is that you need to perform.
I need to be able to do things as soon as possible, as fast as possible. Absolutely. And I'm willing. So, okay, here's the deal. In 90% of the cases, how many requests, how much load do you need to say, okay, this is fast enough? And for many people, the value is relatively low. Hundreds to thousands of operations per second is wow. I have to deal with users who think that, uploading the entire database once a day is the way to go, and I need to complete in under 5 minutes. I have to deal with users who are running benchmarks and make decisions based on that. So, and obviously everyone wants to be better. Another thing that is really important, consider this case. How much time do you think one of these requests took? It couldn't take long because otherwise we wouldn't have enough time to process all of those. And the reason this matters, it matters because you have to be able to say, okay, if I have high performance, and if I'm able to run to a level that is absolutely ridiculous compared to what you will probably need, I'm also able to do something that you probably actually really need. And it is the ability to give you answers on your queries with very minimal latencies. So instead of having to say, oh, let's wait 100 milliseconds to get the results, I can give you that in 1 millisecond. And that matters a lot.
Yeah.
Cool. So I have another question, Oren. Nothing related to this, but as we just discussed previously, it's very easy to do bad decisions, to make bad decisions about when you are adopting or moving to NoSQL, right? So what would be the best resources for developers that want to get started with Raven or play with RavenDB?
It's
not only get started, but where they can find the best practice.
I would say this is the place to start. This is a book I wrote. It's about 600 pages, something like that. So it should be and it's cover a lot of pretty much everything that you need to know. There's also weekly webinars that we're doing. And they cover all sorts of interesting details about how is RavenDB, this one I really love. How you use RavenDB as a queue infrastructure, and what are the features that are dedicated for that. But the place to start, if you want to understand everything, go to Learn inside of any book. It gives you all of the details. And,
Come on, Oren. I was expecting that you would recommend the RavenDB bootcamp, but it's okay. I am not angry about
That is the second best one.
No, it's actually an issue because Thiago asked, how do I get to know everything? If you want to get started, the bootcamp is the way to go.
Yeah. I know the guy who wrote this bootcamp.
Yeah. So all sort of a walkthrough, and here you can have demos in multiple languages that explain how to write how much of code.
Yeah. That's amazing. That's amazing. Oren, you're a kind of hero in the .NET community. If I'm not wrong, you got recognized as a leader in the NHibernate project. People in Brazil keep asking about when Oren will be back in the NHibernate project, trying to improve it. Any changes? Any chances about it?
I don't think so. I'm still doing actually non-trivial amount of work in Hibernate, but not in the Hibernate project itself, but for clients using Hibernate. And I do a lot of work for helping to optimize and build a system using Hibernate. It's typically, okay, let's run the profiler. Now let's see what the results are. Okay, here's how we're going to dig ourselves out of this hole. And it's really funny to see how something's changed a lot, and you can see that I have no idea how people do UI these days. Like what you see on the screen, this is magic, absolute magic, and people do. If you paid me and okay, how do you do this sort of things and this stuff? No idea, magic. I got a really good guy who is doing a user interface and UX, and he's like, wow. But the database stuff, that's mostly unchanged, and that's for the good and bad. Because if you have learned stuff about the database, it's still very, very much relevant today. But when was the last time you used jQuery? I don't know, by the way, if people still use jQuery. Last time I wrote a UI, people laughed at me because I use tables for positioning, but it works. And I wanted to move on. Yeah. So database stay very much the same, and unless you write a new one. And it's interesting to see how the challenges of solving them are so different. So, Thiago, you asked me about how people can learn and what are the pitfalls. One of the things that I explicitly did with Raven is trying to figure out what are the pitfalls and how to avoid them. Yeah. Because I kept seeing them over and over again. So let's go and look at something like this.
In fact, that was one of my questions that I prepared to you. What was your motivation to, dive in this world? Because when you launched Raven, there was, CouchDB probably, Mongo probably.
Couch, Mongo, Hayek, Project Voldemort. There was the Hashiko. Like Hashiko, I don't remember. There was a whole bunch of people. I think that Couch and Mongo and Raven are the only one who actually survived the long haul. And the reason I did that was that I knew that the database was a problem, that people kept falling the same pitfalls. Because again, look at the data. Where is the data? Look at something as trivial as this. This is an order, and it fits in under 1 kilobyte. Perfect. If I put that in a relational database, I have to put it in 2 different tables at the minimum. And a reasonable order schema would have the data of an order spread across 15 to 25 tables. Now consider the cost of, I need to show a single order. Okay, let's do 15 joins. Let's take your performance and run over it, and then run over it again, and then set it on fire. Because, and again, I now build databases for a living. I understand what you ask the database to do. And there is no way to do that efficiently. Now, I really wanted to use something that solved the problem. And remember, we're talking 2007 to 2008.
Yes.
I had a review of CouchDB from 2007. Let's see, 2008. And I remember going through that and being really impressed. You can see that there is a whole bunch of Error code here, which I don't want to see that anymore. I was really impressed by the concept, but the execution, it's like juggling knives. If everything works, it's really impressive. If you sneeze, you have to pick up your fingers with your mouth because you slice them off. And I couldn't come to grips with, okay, here is a relational database, everything is safe, I have transaction, everything is known. Here's this strange world of NoSQL where everything is so dangerous, so complex, stuff like that. Let's see if I can find this one. This is, I think, the best comic for a MapReduce for NoSQL systems at the time. And it was just like that. If you wanted to do something, go and build everything yourself. Some of those systems didn't have a UI, didn't have a way to query the data. Memcached still doesn't have a way of querying data, which is, what keys do you have? I don't know. I'm not going to tell you. Yeah. So the primary motivation of building RavenDB was that I wanted to have a transactional store. I wanted to have something that you can start and use and not really think about, and to get things working. The usability factor of RavenDB was one of the highest criteria that I had to get started with. Now, let me show you what I think is one of the best features of RavenDB. This is a feature we had since 2010. Yes, orders do not have a first name. Yes. So you can see that it took me a bit of time to run this, but it's find the result. And here is the relevant index. Let's try everything from scratch. Let's run it again. And here we have an index. Now let's try this again. It's another index. Now I have two of them. First name and last name. Now, in about 5 seconds, this one is going to go away. And the reason it's going to do that is that it's now no longer needed. So it goes, bye-bye. Now, what just happened? I made a couple of queries. RavenDB sent a query to the query optimizer. The query optimizer analyzes the query and says, okay, I don't have a way of running this sort of query effectively. In a relational database, this means, okay, let's go ahead and do a full table scan. With RavenDB, the database says, okay, let's do a table scan, but instead of just doing table scan and throwing away of this form. Let's go ahead and create the index. And the more queries you make to the system, the faster RavenDB becomes, because you give it more information. Now, search. Here's a good example. Give me an example of. Give me all of the users who have German in the notes field. So she's fluent in German. And this one I'll probably have somewhere around here about German, but I don't know how to find that. I ask RavenDB to find it, and here is, let's do 60, I think. Here's more context. So try to imagine doing queries like that in SQL or pretty much any other database that you want. And the complexity of having to manage that is huge. Now, the amount of responsibility that you have at the hand of the DBA is huge. And that means that things get missed. Because, no DBA is going to be perfect ever, and you always have new queries and stuff that you need to figure out. If we go and look at the test database, here we have 176,000 orders. This is going to take a while. We have 176. Okay, not that while. Okay. Now let's try to send it to the UK. And you might notice that it took me 3-something seconds to search Brazil and 3 milliseconds to search the UK. Again, look at this. Why is that? Actually, I'm using a cache. Let's disable the cache. Take me now 0 time. This is because we're now using, what is that? There we go. We're using this MapReduce index. We did an aggregation query. We told RavenDB, I want to aggregate stuff by the country. So it went ahead and did that. And a query on hundreds of thousands of records becomes instantaneous. We can actually see how that works. Let's look. What another one? Here we go. So I can see here we have 3 documents that was shipped to France and 1 document that was shipped to Germany. And here are the results of the map, and this is the total sum here. We have another 30 options. This is the total sum here. And this is how RavenDB is able to go in milliseconds from having a query to give the results. We've already done most of the work. But I don't know if you noticed, but I'm doing a deep inspection of how RavenDB works. We previously looked into, okay, what's going on with the disk? How much disk space we're doing? We can drill down to individual disk writes and figure out what exactly is going on. Oh, I can see that this write took so-and-so. It was actually really fast, which is awesome. But if it's not awesome, I would be able to tell from here. I would get a warning here that means, oh, there is an issue. I can go to a production system and ask it questions about itself. I mean, this is part of the baseline team that you don't need to do anything about. And the whole team is about trying to reduce the amount of friction that you have when you're working with the database. The more we are able to take upon ourselves, the less you have to do, the more you're able to focus on, getting things done rather than reading about how does it work when the moon is in retrograde, whatever that is.
Perfect. Oren, I think we'll have a last question because you're getting a lot of your time, and I know your schedule is not a thing. What would be your recommendations for developers who want to improve their skills and to know how to write like you, man?
Read code. Read lots of code. Go and find projects that are in areas that are of interest to you and read them. Now, I have a lot of reviews in my blog.
Yeah, you're very famous about that.
Yeah, and some of them, and the reason I'm saying that, this is a database from Microsoft, written in C# and C++, that does some fancy algorithm stuff. And I went and read through the code, and you can see that I'm looking at stuff at this level. And I think it took me a few days to go to that. And it was a non-trivial investment of time. But it means, and again, you can see the number of possible. This one was fun. There is a project called Lemon Graph, and I review how it works and why it's doing that and all sorts of stuff like that. And that meant that I could much better understand how she looks so smug. Sorry. Like, really and that means that I could better understand how other people solve problems. Now, if you're not likely to figure things out, you're likely to go and look at a piece of code and stare at that for an hour or two and just look, what? If you can debug through the code, try to understand what's going on there, go and ask questions. In my experience, I have found 0 cases, especially with open source, where you ask someone a deep technical question about how a piece of software works, and they weren't very happy to tell you about it. In fact, I think there is one case. The game Descent. I'm trying to remember who. I read it a while ago that it was open source, the game engine, and they asked the team, "What do you think we could learn from that?" And the answer was nothing. Don't look at that. It's not worth it. Apparently, it was full of big hacks to get things working properly. But beyond that, the idea is that go and read and run through the debugger and ask questions, and you will feel stupid. Apparently, there is a code base I read in 2013. I read it to the point where I read every single line multiple times. I debugged through it, everything. And this week I realized that I made an assumption that was fundamentally wrong, and it changed significantly how some piece of the software that I reviewed worked. And I'm like, how could I ever have missed that? And yeah, I mean, it's really something ridiculous like that. So you will feel stupid at some point because you stay in the code and you don't know what's going on. But the key here is that the more code you read, the better you learn to recognize patterns that transcend language and platform choices. You will understand, oh, you know what? Let me show you something. Here's some code.
Okay. Can you zoom it?
Yes.
Yeah, perfect. Thank
Okay.
you.
So this is the code that I'm writing, and if you look at that, this is a piece of code that is implemented in hash table using a open addressing with linear programming. And most people only run into those terms at a data structure class. And then it's one slide, moving on. You don't need to know that. Use a dictionary. Okay, yeah, but if you want to do to be a professional, you need to understand one or two levels below where you're working. One of the things that I really enjoy doing, I was involved in the CASA project, 15 years ago. And the lead project for CASA was called Hamilton. And he wrote a piece of software called Dynamic Proxy, which did runtime AI generation. And it was black magic. Like, try to imagine that you're looking at code that emits, instructions. And if you had an error, you would get the bad runtime error, or the runtime would crash, or stuff like that. And I remember spending so much time on that code base and working on it. I actually fixed bugs there eventually, and got to a point where, oh, you know what? Runtime code generation, this is now a tool I can use. And oh, you want to access a private field, and we can't use reflection because that's too slow. Okay, let me pull up the dynamic AI generator, and we can do that in like 10 lines of code. And then you realize that if you haven't had that experience, what I'm doing is now black magic. I'm like, no, this is not even gray magic. This is like off-white. So read code. That you have. If you were a piano player, you would play. You would play and practice. You need to keep your hand sharp. You have to build muscle memory. In the same way, you have to be able to look at this and understand, okay, what's going on? Okay, I can see from the pattern of the code what it is doing. Now, sometimes it's opaque. Sometimes people do feel like what they need to do is they need to do fancy stuff. Like, what is that? Like, I have something here. And that's the range search over a bitmap of bits. And I honestly don't expect anyone to try to understand that without looking at the documentation or debugging of these multiple types. But the whole idea is that you want to know that when you get to something like this, it's like, okay, deep breath, take a sip of coffee. I know I can handle that. Because the mindset is typically, I don't know how to handle that. That's black magic. That's someone else's code that does things that are not immediately obvious. Can't handle that. Can't touch that. Let's code around that, which is suboptimal.
Perfect. Oren, I would like to thank you very much about all this learning, and thank you also, Thiago Custódio, for your company. I think you will both learned a lot with my friend Oren. It's really nice to see people who wants to learn and understand 2 levels below, to read code 2 levels below of your current position, of the current needs of your software development. That's an amazing idea. All right, again, thank you very much. This was a master class for me, and I'm a big fan of your, and you know that. And again, thank you very much.
You're welcome.
Guys, see you next time. I